in the heart, the generation of pressure, blood flowing, valves moving, to the electrical events that are responsible for this. Right? So we have to have, right, again, to get back to tie this in with what we talked about last week, we have to have a discussion about how are these different events connected to each other, right? How do we have an excitation here coupled and cause a contraction here? The force, the power stroke cycle, exactly the same. So the 90-degree high energy, 45-degree low energy, the swivel back and forth, the use of ATP to recock, the changes in affinities and all of that, exactly the same. What is different is the regulation of that connection between depolarization of a sarcolemma here, which is what this is, with physical events that are occurring with actin and myosin here. So that excitation contraction coupling. So that's one of the things that we want to get to. Now we conveniently label this in lab on Monday next week, Monday after break. Okay, we're going to look at these. We actually will be performing EKG tracings on a lot of people in class, and we'll be looking at patterns, both patterns that is everybody normal or abnormal? We can look at that. And then also about asking questions about how does this electrical activity change in response to different activities. So we'll be looking at how does this change in response to a parasympathetic stimulation. So we'll be doing things that would cause you an activation of your parasympathetic nervous system. And how does this respond to sympathetic stimulation? So we'll be doing things to cause this to respond to sympathetic stimulation and asking questions about how it changes. We know heart rates change with sympathetic and parasympathetic. Parasympathetic slows it down, sympathetic speeds it up. So that means this either, if the heart rate increases, this gets closer together, right? If the heart rate decreases, this gets further apart. Or what we call the interbeat interval, the timing of another event, this distance right here, in between beats changes, right? So we do a cardiac cycle. If we want to speed it up, we'll shorten this to have another cardiac cycle faster. If we want to slow it down, we'll have that out there. And so there what we're saying is we're regulating the SA node. Okay. Yeah?
I'm just like confused why